What exactly is expected value? Well, you can think of it as kind of an average of all the values that we expect to happen when we have an experiment. Imagine that our experiment is spinning this spinner. And if we land on yellow, we'll win $1. And if we land on blue, we'll win $5. Now, one way to figure out average winnings might be to just run the experiment a certain number of times and average the outcomes together. So we could do that. We could maybe spin and get a $5, and then spin and get $1, spin and get 1. Next spin is 5, and our last spin is 1. So we could average those 5 spins together and come up with an average value of 2.6, or in this case, $2.60. But we only did 5 spins, and we'd really like to generalize this a little bit more. So let's take this same spinner and let's find the expected value for any number of spins. In other words, a theoretical expected value. So we notice that the blue takes up about 1/4 of the spinner, so its probability is 1/4, and the yellow is about 3/4 of the spinner, so its probability is 3/4. Now each of those outcomes, the blue and the yellow, also has a value associated with it. The blue has a value of 5, and the yellow has a value of 1. So we could think of this as 1/4 of the time we expect to get $5, and 3/4 of the time we expect to get $1. Now that's the idea that we can use to find the expected value. So if 1/4 of the time we get $5, and 3/4 of the time we get $1, we can multiply 1/4 times 5 and 3/4 times 1 and add those together to get the expected value for this spinner, which is 2 or $2. Now what that means is that if we spun this spinner over and over and over again, kept track of the values, that in the long run, on average, we would expect to win $2 on each spin of the wheel. It doesn't mean that we can win $2, because obviously we can't. We either win $1 or $5. But our average winnings would be $2 per spin. So let's look at one more example. And we're going to think about something that's called a duck race. This is something that happens quite often with charities. And what they do is they sell you a duck, and then your duck is put in a river, and it goes down the river along with all the other ducks for all the other people. And the winning duck wins money. So in this case, whoever had duck number 14 would be the winner. Everybody else would be a loser, but their money went to charity. So let's suppose that in a duck race, there are 1,000 ducks being sold by the charity. Every duck will cost you $2. And if your duck crosses the finish line first, you will win $1,500. So what's the expected value for each duck? Now, in order to do this, we'll do exactly what we did before with the spinner problem. But let's organize the information a little differently. You may find this an easier way to take all the information and put it in a readable form. So we're going to use a table. Now there's 2 possible outcomes when you buy your duck and you race your duck. Either your duck's going to win or your duck's going to lose. The probability of your duck winning is 1/1000th. There's 1,000 ducks, there's only one winner. And the probability of your duck losing is 999 out of 1,000. So what's the value of a winning duck? So you may think, well, the value's $1,500. If your duck wins, you win $1,500. But here's the catch. It cost you $2 to buy your duck. So the value of a winning duck is actually $2 less than the $1,500, which is $1,498. That's how much you'll net if your duck wins. So how about if your duck loses? Well, you don't win anything for a losing duck, but it did cost you $2 to buy your duck. So the actual value of a losing duck is -2. You lost $2. Now for each of these possible outcomes, we'll multiply its probability times its value. So for the winning duck, the probability times the value is 1,498 over 1,000. And for a losing duck, it's -1,998 over 1,000. To get the expected value, we will add together those two fractions, the probability times the value. And we'll end up with an expected value of -500 over 1,000, which is -0.5. Since the values were expressed in dollars, that means this is an amount of money expressed in dollars. So it's actually a loss of 50 cents. So mathematically, should you play the game? Well, mathematically, no, because on average, you will lose 50 cents every time you play. But in real life, do we play games like this? Of course we do, because it's for charity, and we don't mind losing a little bit of money if it's for a good cause.